Alrighty, welcome back to Hypo Driver. Today we're going to pick up the series on the advanced workbook for Pi Toolbox 14 for iRacing. Been a little bit since we did the last section. Partially that's because, I'll be honest, I'm a little intimidated about this one. Today we're going to talk about the worksheets they created related to suspension tuning. And so I'll just say right up front, my knowledge of race engineering a car as far as suspension tuning is what I would probably consider intermediate at best. And so I had to do a little bit of digging, make sure I can give you all some good examples. Look, if you're a professional race engineer, or you're someone that does engineering or does suspension design and tuning for a living, this may be a little basic, although we'll at least give you a look at what the workbook provides. But really, if you're kind of new to this stuff, you're just getting started, I'm going to try to give you some good examples. There's a ton of good resources out there. A lot of good stuff on YouTube. Just as we walk through this, particularly shock histograms, you'll see there's a lot to dig into there. But I'll try to give you the basics and then walk through at least two tabs or two worksheets. We're going to go through damper displacement and damper velocity. And then depending on how the time looks, we might get into the roll pitch, ride height, aero tab as well. So ideally try to get all of the suspension stuff in one video. So again, if you have any feedback, please leave it in the comments. If you think I botched something, please leave that as well. Very open to feedback. Let's go ahead and dive right in. Here we've got, I just again did file, new workbook, and chose the plus workbook template that they have. I also should note that between now and the last video, there was an update to the workbook. At some point, I'll probably go back and review some of the changes, but they added some things. And then I think probably the biggest news here is initially, if you're just running Pi Toolbox Lite, the actual suspension or the damper shock channels weren't available. They were only available in plus and higher SKUs. Cosworth has unlocked that. So now all licenses have access to all the channels. So there's no longer kind of a difference. So you could, if you wanted to, make your own workbook, but honestly, it's worth kind of modest sum to get a plus subscription and get this workbook along with the real-time telemetry capabilities. So, all right, let's dig in. So we're going to go to the damper displacement tab, and that's where we're going to start our day today. So some great things over here. First thing is you get a nice tabular report of all your suspension settings. In my case, I have an Aston Martin GT4 data, so there's not a lot that you can change. So probably wasn't the best car to pick, but for cars that have a lot of configuration, you can go ahead and see what you did, see how you set it up. One thing I'd encourage you to do, it's kind of great to be able to do this with a sim, is do things like a shock sweep. So take a car that's got a lot of configuration and, just go out, set everything full soft, run a couple laps, up at a couple, run a couple laps, and just save that data, and you can start looking at it and actually seeing the differences in the traces to get an understanding of what that does to the car. So I would encourage you to take notes so you know what changed as you were driving the car, how it felt. But more importantly, you'll get a sense of, okay, what does that look like differently in the data itself? Now, in this case, in this particular worksheet, we've got, again, the list of settings. We've got your track map, so you know where you were on the track. Down here, we've got some fairly fundamentals, so steering angle, speed, and then shock deflection. So this is basically how much the shock is moving, up or down on its stroke. And so we see those values here. I'm going to make one change that I like, which is I'm going to right click and I'm going to go to layout, and I'm going to do show segments and splits, so I can actually see the little bar of what corner I'm in. And now, for me, I do tuning on my Corvette, my real track car. So that's most of my experience here. And so a lot of this is things that I would look for in that. And typically I tend to start by saying, okay, let me pick a corner and then think through the corner as far as corner entry, like basically when I turn into the corner, kind of middle of the corner, steady state, and then quarter exit. And is it doing something I don't like or that I want it to do differently? And then really drill into that and understand, okay, like what is the suspension doing? What am I doing with the throttle? What am I doing with the brakes? What is the yaw doing? And so like you can look at the car holistically across an entire lap, and we'll do some of that here. But also I find it super helpful to just pick a corner or two where the car is behaving in a way that you'd like to improve and really, really drill into that. And so, in this case, frankly, out of the box, the Aston's pretty good, at least for me, pretty easy to drive. But like, let's pick some areas to look at. So the first thing is right here. If I just zoom in, I see this area where, in this case, the left rear shock, it's kind of flatlined there. So, why is that? Well, in this case, you can see I've got 30 degrees of steering angle. This is turn 3 at VIR, so it's a left-hander. It's a pretty high-speed corner. This is actually approaching it, so you're kind of bending through 2-3. And, this would be the left rear, so it'd be the inside wheel. So here it is. It's basically in a steady state. Kind of has me wondering, is it fully extended? Because you do see movement on the outside rear where it's still kind of, you're getting more compression here as it add more steering angle. So that maybe has me wonder whether there's some setup change to think about where it's getting unloaded. But if you look, it's not actually at its maximum from a droop perspective. So if you just zoom back out again, you can see there's some places where it's actually down a little bit lower. So, something to think about. I'll be honest, I'm not quite sure what I would change right now just because of that. The car felt pretty good, but I'm looking for those outliers. I'm looking for something that indicates maybe there's a problem. So, this is giving you the time distance chart view of the suspension as it moves. Again, on my real car, if I see something like, again, a corner going completely all the way in, all the way compressed, then I know I've got a problem. But over here on the right-hand side, what we have is same data as far as shock movement, so damper displacement, versus the speed of the car. Okay, so one of the things this kind of gives you, if you squint and you look at it, you can kind of see a line where as the car is going faster, you're actually seeing kind of the trend move up a bit. So that's actually from the Aero. It's a good thing to kind of be able to see. But in this data, I'm looking primarily for these outliers. Okay, so, maybe down here in the left rear, we were just looking at that. Again, I see all these markers down at 0, right? So 0 is actually, I believe, kind of ride height where you're just static. So again, it might be worth looking at whether I'm not, unloading the wheel too much and there's something I need to do to kind of support that better. More importantly, what I'd be looking for is up near the top on the compression side. Are there cases where I see a lot of dots kind of right next to each other, indicating that maybe I'm bound up, like maybe I'm fully on the bump stop and the car is just kind of resting on them because it's sprung too softly. So I don't particularly see that here in any cases. It's also worth just kind of pointing out that, again, just because 2 dots are next to each other or 3 dots or a bunch of dots are next to each other on a graph, it doesn't mean they happened right next to each other. Again, they could be different parts of the lap that just have the same value. So in this case, if I just kind of cycle through them a little bit, that's turn 16, 17, 16, 17, 16. Okay, so that's all kind of the same part of the car. But just something, don't let yourself get kind of sucked into this idea that if 2 dots are next to each other, they happen necessarily in series. But you can cycle through them with the arrow keys, left and right key. That's what I'm doing here, just kind of going left and right, which is literally advancing and moving the timeline over here as well as the dots. Okay. Let's see. I think that's about it for that chart. So let's look at damper velocity. So this is something that's really cool if you know what you're doing. So here what we've done is plotted your classic shock histogram. I figure it's worth noting, since I mentioned earlier kind of like the light license. The histogram's only available with plus and above licenses. So you actually couldn't replicate this unless you got at least a Plus subscription. But they did a really nice job of laying this out. So what you're seeing is each corner of the car, left, right rear, left rear. And then above it, what they've done is given you bins that represent low speed, medium speed, high speed. So this is all in millimeters per second. You'll find if you start reading up on this, there is, different views of what's low speed and what's high speed. Some people say 25 millimeters a second, but in this case, we've got it defined as 40, which is good. And what are you looking for here? Well, there's a couple of things. So one, you do want this nice shape. You want it to be something where, I guess I should point out, like, this is speed of the shock. Okay, so this is shock moving slowly. This is shock moving very quickly. Okay, so if I see nothing but a lot of very slow movement, that tells me that my shock is probably too stiff. Okay, conversely, if it's too flat, that generally means that my shock is too soft. Okay, because I've got a lot of high speed movement because it's not adequately damping the spring underneath of it. But in this case, the shape is generally pretty good. The thing you want to look at next is everything above 0 is compression. Everything below 0 is rebound. So, if you're thinking about clickers on the shock, this is effectively your shock going in from steady state. This is it going out from steady state. And ideally, again, a lot of caveats, suspension engineers will probably kill me on this, but you really want it to be pretty symmetric. So in this case, we see a little bit of a bias towards rebound on the low speed side. So, you may want to go ahead and make an adjustment, or at least play with an adjustment on the front. Again, that's a left front specific thing, although it's primarily right-hand corners on this track, so that's not uncommon. So, maybe we want to take a click out of the rebound and just see what that does to the car. See how the car feels, see what that does to the trace. Similarly in the rear, you do see it's a little bit, if you will, pointier. So it kind of indicates, slightly stiffer in the rear. But I'll give you an example just because I was playing with my own car, data from my own car. This actually came out of the PDR. It's not nearly as high resolution, but I'll give you an example of what something that doesn't have the shock set rate look like, or really spring rates look like. So we'll just bring this up real quick. So here you've got slightly different view, but similarly, this is shock velocity, left, right rear, left rear. And you can see big bars in the center. And in particular, if you look at this left rear, I should point out in both cases, it's percentage of time spent in that bin. So in this case, I've got a left rear with 50+% of its time in low speed. So the rear is just frankly way too stiff on the car. And that's more a function of, I believe, bars and springs than shocks in this case. So I'm not going to fix that with shocks. But just to give you an example of something that doesn't look quite as clean as what we're seeing in iRacing out of the box. So again, just to kind of come back, keep an eye on your percentages here also. Like again, this is all 8%, 8%, 8%, 8%. I don't know that this is fixed or auto scale. So let's actually look real quick. Yeah, it's auto scale. So you could very much have a chart where they look even, but the top of the chart instead of being 8 is 50%. So just keep that in mind as you're looking across your data, that you understand what your y-axis is and whether it's the same as the one you're comparing it to. Okay, and then one more thing. You will notice in the Pi Toolbox workbook, there are math channels to derive the shock velocity. There's also there's native channels in iRacing for shock velocity. There appears to be some scenarios where the native data can be a little inconsistent. And so they just added math channel to derive it from speed. So I'm going to show you that real quick. So let's go math, edit, and then we will just find, so here we go. So this is shock velocity calculated, and all it is a derivative of the shock velocity. I'm sorry, the shock deflection. So native channel, derivative of it, gives you the velocity. So they've go ahead and that's what they're using for these charts are actually the calculated values as opposed to the native ones out of Pi Toolbox. Or I'm sorry, out of iRacing. And then on the top here, this is pretty cool. So they've gone ahead and set up channels to represent compression and rebound. So again, compression is just values greater than 0, rebound is less than 0, but now you can go ahead and look across your session, across your laps, and basically say for each corner of the car, how much time am I spending in compression? How much time am I spending in rebound? So again, give you an idea of whether you've got some inconsistencies here or some imbalance, if you will, between compression and rebound, as well as just, whether I've got laps where something unusual happens, like perhaps I've got a shock failing, and now I start seeing, a lot more time or a lot more movement, if you will, in the shock. So nice chart they added. Again, there's probably lots more uses for that I'm covering here. And then let's go over to the next sheet. For me, this was particularly cool because this really focuses on Aero, and then we're going to talk a little bit about kind of balance of the car. So what have we got? Well, again, we've got another display showing you kind of some of the settings, primarily focused on Aero. So again, wing settings and such. We've got a nice map showing Aero balance. So we'll talk about that in some more detail, but what you're seeing is basically how the balance is shifting to the front of the car. So the darker the blue, the more towards the front the Aero balance is. I'll note right up front, the Aero balance channel is using your ride height channels. It isn't actually averaged out. So you're going to have rapid movement as a result of just things like bumps and cornering and braking and accelerating. So understand that it's kind of an average over time to look at. And that's why, for instance, here's the run up the back straight, or the straight bridge straight between the lower and upper S's, and here you see it kind of going up and down as the car is just kind of bouncing as it goes up the straightaway there. So maybe let's just take a quick stop here, take a look at the Aero channels and Aero balance channels just again so you can see what's involved. So we'll go back up to our math editor and Aero balance. Here you can see it's 2 more math channels. So it is front aero load divided by effectively total aero load and then made into a percentage. And then if we want to go look at what front or rear aero load is, what you see here is we're taking static ride height plus current ride height, averaging it out on the front, and then effectively multiplying it by the spring rate to derive a force on the car based on the amount of displacement of the spring and the spring rate. So I actually did a video similar to this on, I think it was the ZR1 a while back, because we had known spring rates on that. So nice tool. Just understand again its limitations, that it is, as the car bounces up and down or you accelerate or brake, you're going to see changes to this. It's best to look at it as a trend more than anything, or look at it in steady state. One thing, by the way, this is kind of a technique you can use if you want to get kind of a cleaner look at aero balance. Maybe just want to take a lap, go out, accelerate to some reasonably high speed where the track is straight and it's flat, and then just lift and let the car coast down. And you can actually get relatively clean data that way of how the aero is affecting the car. All right, so that is your aero balance chart. Over here we have, we've previously looked at the GG circle. This is G sum. So this is, again, the tangent that represents both longitudinal and lateral G's, kind of the effective force on the car. And we've got it color coded based on effectively less than 1G all the way up to greater than 4G. So frankly, in a GT car, at least the way I'm driving it, you may want to go ahead and kind of change these. And actually, let me show you that real quick. So I think I've done this in previous videos, but Alt-3, do it again, G-sum, color gradation, click here, I can change these values, and maybe I want to do it every half G above 1G, or it's 1.5, 2.5, 3. But anyway, this is a nice graphical representation of G load into the car as you go around the track. So again, there's a lot of time in that 1 to 2 Gs, a little bit of time kind of greater than 2 Gs you see in through here. And then obviously this is kind of straightaways where there's less than a G in it. So, and then down here, again, they've added the bar displays or the strip displays to show you yaw and lateral acceleration as you're going. This particular sheet doesn't have one of those, you know, kind of play buttons that the others have had where you can kind of play through it, but just use your arrow keys and you can just, you know, literally right and left arrow key, cycle your way through, and you can watch kind of how the displays change as you go through. I do want to go back. There's something I forgot to mention as we were talking about this. Let's go back to damper velocity. So if I go over, well, actually we did this. So I go to damper displacement and I go here. I zoomed in at one point, right? So I'm going to zoom back out, just hitting the backspace key. So I'm zoomed all the way out for the lap. And these are my velocity charts, okay? And that is representing the lap. Okay, but I think this is a bug, but you can actually see that it didn't zoom in along with the, when I zoomed in with the data. So what you can do is we'll go ahead and zoom back in real quick. So I'm going to go back over here and I'm going to zoom back into this section, say. I'm going to hit the Z key, zoom in. I want to show just that area from kind of 2 to 3 that we were talking about early on. Go back over here. This should have zoomed into just that section. It didn't. If you find that happening to you, just go up to display, unlink zoom, display, link zoom. And I have to do that for every one of them. But this is really cool because now I'm looking at the shock histogram just for that section of track. So I can look at, you know, turn 1, or in this case, turn 2, 3, and say, okay, is there something in there, you know, compression rebound wise that I need to tune on the car? You know, so here you see, you know, the right front, this is, you know, against the left-hand corner. It's pretty heavily into the rebound. Maybe I want to try taking a little rebound out of it or adding a little bit of compression to it. Let's go ahead and just do this across all 4 of them. And you can see a big spike here on the right rear also. So again, like I like to look at this kind of in specific key areas of the track. And so this allows me to, anywhere on the workbook, zoom in, look at a section of track, zoom back out, or look in, and then go over to a different view, say the shock velocity, and look in more depth. So here we're just going to do turn 1, same thing. So again, just a really useful tool to allow you to look at very specific areas of the track and not just like holistically a shock histogram for the entire lap. All right, a little diversion. Back to where we were looking at the roll pitch ride height arrow. Over here, I'm going to actually zoom back out again. You can see these are all linked. Again, if you ever want to unlink them, you can also do it here. There's this little kind of padlock. So here, what they're doing is they're showing wherever it looks like you're up on a curb. And so this is just shock velocity greater than some threshold. So the actual curb strike channels will show you that. So gives you, again, a good way to graphically say, okay, was the instability I felt on the car a result of a curb strike? And so you can actually see that in the data. So, you know, I've had scenarios where I've lost control of the car and I didn't know, like, was I on a curb? Like what happened there? And you can actually look and see, okay, oh yeah, the movement of the wheel or the shock velocity will tell me that I actually was on a curb at that point. And that's why the car was, I lost control of the car. So again, we have that. And again, we have the ride height data to dig into. On the right, we have roll and roll rate. So roll velocity. So this is how much the car is rolling in a given corner. Again, I'm going to go turn this on my favorite little Show segment. So here you can see big roll going into 2, and then it kind of unloads. So this is that same area we were looking at initially. And then you can see how fast is the car rolling. So, again, one good thing you can do with damper tuning in particular is slowing down the roll rates. If you find the car is kind of too quick to roll when you roll into a corner, you can kind of jack up the compression a bit to slow that down. So one thing that's not here that you might want to add and look at is roll ratio. So I'm a big fan of that one ever since I discovered it. So effectively there's a front roll and a rear roll channel. So much like you see Aero balance front to rear, looking at the roll ratio front to rear will give you a really good feel for the balance of the car. Getting that right is pretty key for mechanical grip. And then down below here, again, we see a lot of kind of fundamentals: throttle, brake, a steering wheel angle, lateral acceleration. But then now we're looking for things like wheel slip, right? So this is difference in front wheel speed and actual kind of slip ratios for front and rear. So this could be good example. This is coming out of a corner. If you see a tire spin up, but it's unloaded. This could be also similarly, you're cornering and perhaps you've lifted the outside front wheel or the inside rear wheel. So these are good opportunities to kind of dig in and say, okay, do I see big areas where I'm potentially unloading a tire, and an unloaded tire is not going to help me get around a corner any faster. So really, really nice, useful chart here. And then we talked about Aero balance over here, but here it is. Let me just blow it up real quick. Here it is in an XY scatter chart with a polynomial that really just shows you the trend, right? So I mentioned how it's going to move with cornering and braking and, accelerating, but this gives you kind of that trend. So you can see, at low speed, oops, if you just look on the right-hand side under polynomial, it's around 65% front Aero balance. Or front Aero. I'm sorry. Yeah, the Aero is around 65% front. Whereas you can see by the time we get up near the high speeds, it's down in the low 50s. So what you're seeing is with speed, you're getting, you're effectively shifting the balance a little more rearward. It's still not rear biased. It's still actually neutral at high speed, which is good because it's going to have a much bigger effect at high speed than at lower speeds. But it gives you an idea of how the Aero balance of the car is changing with speed. So you want to tune that, tune your wing angle to try to get that to something that feels, comfortable for the driver at higher speeds and higher speed corners. And then this next one is really neat because they actually give you front, rear, and total. So this is, and you can see it over here, front Aero, rear Aero versus speed and total Aero load. So again, I'm just going to click on the chart and use the arrow keys to go up and down. So the front Aero is the red line. So you can see, the front Aero starts out actually at a much higher value than the rear Aero, which is the blue line. So you've got a lot more front grip or front Aero grip at lower speeds, but it's not growing as fast as the rear does. So you're actually gaining rear Aero grip with speed. Again, you could adjust this with wing angle, and then this is the total Aero grip for the car. So great way to be able to look at the Aero balance of the car and, ask yourself, do I need to adjust my wing angle to get a better high speed balance in the car? All right, I think that's everything. So that's the 3 suspension tuning channels. Again, there's a lot here I didn't cover. There's a lot more you can do. But again, feel free to ask questions. Again, go easy on me if I got it wrong, but this is kind of how I use these channels, these workbooks. And I'll be back with video 5 where I'll cover the remaining channels in the workbook. Thanks. Have a great day.